Our presentation today is ROCKWOOL Passive House and the 2030 Agenda for Sustainable Development. And I just want to introduce a little bit more our team. I'm really happy to have Alejandra, who's sitting right across from me. Alejandra Nieto on board today. She's a certified passive house designer and also active member in several ASHRAE technical committees. And in her role as ROCKWOOL Sustainability Manager, she defines and implements our sustainability strategies and initiatives. She works hard on developing our high performance products and to keep the embodied carbon footprint as low as possible. She's my go-to person when I have questions, when I don't understand. And I know she's a good resource for everyone who has questions about sustainability. Then you probably remember Robert Blount from previous spotlights. Robert works in the passive house community in New England. He's working on his CPhD right now, so good luck to that. He's also involved in local building enclosure committees and active on RENA. Myself, I'm also a certified passive house designer, involved since probably 10 years in the Quebec passive house community as chair, on and off chair of the Passive House Association in Quebec. And with Alejandro, we're basically the Canadian counterpart to Robert in the US. So our agenda for today, we want to talk about obviously the United Nations Sustainable Development Goals, the science-based targets that drive the development of resilient buildings and decarbonization, by highlighting also the sustainability report that ROCKWOOL publishes every year. So Alejandra will talk about that. And then we'll see how that leads into, or how that connects with passive house buildings, especially with retrofit projects. So that's the second part of the presentation. And then we'll highlight some specific ROCKWOOL solutions. So I think with that, I'm going to pass it on to you, Alejandra.
Right. Thank you. And so as Mahnaz was just introducing, so I'm going to talk a little bit about ROCKWOOL's drive towards sustainability and what our strategy kind of looks like. And essentially, our strategic approach is that we are aligning ourselves very closely with the UN Sustainable Development Goals. So back in 2015 is when we first introduced this whole concept of, we want to make sure that everything that we do from a company, from a corporate perspective, from a manufacturing perspective, is aligned with these goals and is essentially kind of increasing the sustainability, of course, maximizing that positive impact that we have to society and the environment, and at the same time reducing our operational footprint, our operational carbon emissions and greenhouse gas emissions as a whole at the same time. So as I mentioned, we have committed to 11 of the 17 SDG goals right today. And of course, I think as any company who has these sorts of sustainability commitments and alignments, the goal is, of course, to make sure that at the end of the day, we're aligning to all of these goals. So I look forward to kind of expanding, to seeing how our company expands to make sure that we are aligned with everything. But 11 of the 17 is a great number, and we are definitely aligned with some of the critical ones when it comes to climate change and climate action. We do have a fact-based approach, and so what that means is we have some sustainability goals that we have committed to align with, along with this alignment to the SDGs. And so we really want to make sure that we are taking a fact-based approach, and also all of our data is third-party verified and assured. So that kind of guarantees that the information that's being put out there is true and honest, and we're being very transparent in terms of, are we actually meeting our goals or not? How far along are we? And in our sustainability report, we definitely talk a lot about what our framework looks like, what are the specific actions that we're currently focusing on. The sustainability goals are definitely anchored at group management. And what that means is, if you're not familiar with ROCKWOOL, with the ROCKWOOL group, is ROCKWOOL in itself is focused on building insulation, but part of the ROCKWOOL group, we do have other companies that focus on different types of products. So in North America, you may be familiar with Rockfon or Grodan that are available to the North American market as well. And I mention this because, as we're going to see in our next slide, when we look at our whole value chain impact, we definitely take a big picture look at all of the materials that the ROCKWOOL group is bringing into the market, how it, going back to that, minimizing our footprint and maximizing our handprint. And so I'm not going to go into full detail of this value chain impact chart. It is available in our sustainability report, but it does give kind of a sense when you're looking to the left. Of course, you can see our manufacturing that touches that is, aligned with our goals that go with climate action, right? And so, of course, we have a footprint associated to manufacturing our products. Every building manufacturer is going to have some sort of footprint attributed to that. But it really is also taking a holistic approach and looking at what are the other values that we're bringing to society, such as, growing local jobs, economic growth in communities, building more resilient infrastructure. We have other goals that align with waste reduction and water reduction as well. So we're really taking a very holistic approach to when we're defining what our sustainability strategy is. And as you can see, as written here, our priorities are fighting climate change, strengthening our business circularity, protecting our water sources, and investing in our people. And I did definitely want to highlight one of the sustainable development goals, which is 17 partnerships for the goals. And I think this is one of the really important ones that, whether your company has official or unofficial alignment with these SDGs, I think this just really is focusing on that we are all in this together. We all have a responsibility to work together to drive decarbonization down, to increase sustainability, et cetera. And so, we are, one of our priorities as, the organization here, so, and, one of the focus areas that Mahnaz and Robert play into is really trying to tie into the different organizations that align with our purpose and working together with the industry to drive the sustainability agenda as a whole, of course. But our title to this presentation was essentially ROCKWOOL Passive House, and how does that tie into the UN Sustainable Development Goals? And so what I did was I kind of took a snapshot of what do we highlight in our sustainability report, and what does Passive House as the institution and the organization highlight in terms of the Sustainable Development Goals that they have aligned with. And what you can see here is that between both ROCKWOOL and Passive House, there's definitely some shared common goals that we are both actively working towards. So, we can both see, as an example there, when we go down to SDG 7 on the left-hand side, we both have some form of commitment and alignment toward that in terms of enabling more efficient buildings in the industry, insulation being a core product that is going to enable that. And then, of course, on the Passive House standard side of things, the standard itself is improving the level of energy efficiency in these buildings and encouraging the use of renewable energy as well. Another great example, again, if you look at SDG number 9 there, again to the left, enabling the more, sorry, it's hard to read exactly.
Durable fire safe.
The infrastructure one, sorry about that. But ROCKWOOL being able to enable more durable and fire safe infrastructure, in this case relating to buildings as being part of the core infrastructure of our communities. And then as well, the Passive House, again, strong focus on that durability aspect, strong focus on that energy side of things. And so I think it's really important, you know, just from a general perspective as the design community, when we're thinking about, you know, what products are we going to use? How are we designing? How are we selecting things? You know, we're seeing a strong shift towards not only focusing on, you know, with the lens of insulation of that R per inch, but what is the whole value impact that that product is giving to the project, but also to society as a whole. And so I think the UN Sustainable Development Goals are a good tool to measure that in a way for us in this industry. And so we did want to highlight some of the progress that we've had toward our sustainability goals. Again, you can find all of this information in our sustainability report that we put out every year. And so back in 2015, when we initially committed to having sustainability at the forefront of our business strategy, these are the 6 goals that we developed and that are verified year over year. So first and foremost, reducing our CO2 emission intensity. So our goal was to reduce it by 20% by 2030. It's 2022, and we are 17% of the way there. So definitely in line with that goal. And in the next slide, once I get there, I'll talk to you about why we're so advanced in that goal, and that has to do with additional commitments that we've made. We also have a goal on the lower left, you'll see there, to reduce our water use intensity. And again, that goal was to reduce it by 20% by 2030. And it's by 2022, we were about 14% of the way there. In the middle, you'll see increasing the areas or the countries that have reclaimed material programs. So essentially leveraging the recyclability and the circularity aspect that ROCKWOOL is and stone wool insulation is by nature, and that it is a product that can be fully recyclable at its end of life. End of life being either, you know, any kind of scraps or anything that come off from the project construction site, but of course, really tying into this conversation on retrofit, when buildings are being retrofitted and they do have stone wool insulation, you know, and the beauty of this product is that it can be taken out from buildings, recycled back into the process to develop new insulation from it. And so that, of course, is one of the goals that we have. Reducing our landfill waste that you'll see there at the bottom in the center. Our goal was to reduce it by 85% by 2030, with an intermediate goal of 40% by 2022. And so it's great to see that we have surpassed this right now in 2022 with being at 51% of the way there. And we feel very strongly that we can get there to that 85% by 2030 goal. And that really has to do with a lot of the hard work that our operationals team do in terms of being efficient, what we're doing on site, on our own sites to reduce waste to landfill. And so a lot of great initiatives happening on that front as well. On the right there, you'll see the energy efficiency. And this is kind of where we're in a way trying to, I guess, what's the phrase, walk the talk? Yes. Walk the talk in that sense of, you know, committing to improve the energy efficiency of our own buildings, our own offices where our employees work as well. So not just focusing on the manufacturing, but how are the buildings that we own and manage performing as well, right? And so we wanted to reduce that energy efficiency use by 75% by 2030. And we intermediate goal by to 35%. And again, we have surpassed that. And our sustainability report is going to highlight some of the key, I guess, case studies of different buildings globally and what they've done to kind of start achieving these energy efficiency strategies. I will go ahead and say that for North America, we are lucky enough that our head office was a new building, and we definitely had the design freedom to make it as energy efficient as possible. So as you can imagine, we have a very, very hefty building envelope and a very efficient building. And so I think that's something that we're definitely proud of as well. to showcase that. And then the last one here on this slide is safety, health, and well-being, which of course, nothing else matters if our people and their plans, if our people on the field are not safe. That is going to be paramount to our business. That's paramount to all businesses, as you can imagine. And so, our goal was to improve, our safety lost time incident frequencies by 10% by 2022. We have surpassed that, but you'll notice that there is a red around it. And unfortunately, in one of our global companies, there was a large incident that, we're obviously doing our due diligence and making sure that, safety is number one priority and assessing the scenario. But ultimately, it doesn't matter how low we can get our lost time. If we have big incidences, that obviously means that there's improvement to be made, and we're working really hard to achieve that. But on our next slide, what I'm going to show you is most recently in 2019, we committed to even more stringent goals in accordance to the Science-Based Target Initiatives. So we committed to absolute greenhouse gas emission reductions of scope 1 and 2 of 38% by 2034. And we also committed to absolute scope 3 emissions by 20% by 2034. And so real quick, if you're not familiar with the differences between scope 1, 2, and 3, scope 1 is essentially the emissions associated to our manufacturing. Scope 2 would be the emissions associated to the energy production that we use for our manufacturing purposes. And then scope 3 is basically everything else, upstream, downstream, that enables us to function as a company and then as a manufacturer. And because these are absolute emissions, that has helped with, if you recall on the previous slide of us being ahead of our original goal, having these additional absolute goals for overall greenhouse gas emission reductions has really kind of deepened our focus on how we're going to decarbonize our facilities. And as you can see here globally, as a company, we've got over the last few years, we've definitely done a lot of improvements to existing facilities, primarily, of course, as well as having specific goals and frameworks in terms of how efficient any new facilities are going to be. And so this is all part of that goal to reach that 2034, that 38% reduction by 2034. And the beauty about SBTI goals and companies that have committed to SBTI goals is that in order to be, approved to kind of say that you have these goals, you have to kind of showcase how you're going to get there. And it has to be, fact-based, backed by science to say that, yes, okay, if you are demonstrate what your strategy is, what your framework's going to be, and then have to, science back that and say, yes, by doing that, you can potentially achieve these reduction goals. You can't just go out and say as a company, oh, I'm going to reduce it by, 100%. If there's no real way of getting there, right? And so another, step towards that, having things third-party verified and validated for the market. And of course, the big picture, why does any of this matter is because globally, we obviously have to reduce carbon emission. We're of course focused on buildings, which we've all seen this stat, up to 40% of carbon emissions globally come from building. And so that's ultimately all of our goals, and we're all in this together. Which comes to the second part of our conversation of focusing on retrofit, because we know buildings have such a huge impact on carbon emissions. Yes, it's important to focus on new construction and to get those to perhaps net zero or near net zero, or passive house standard and combined. But retrofitting buildings is going to be key to achieve these goals. And I've taken the liberty of kind of highlighting some of the UN goals that I think directly contribute towards, that are directly applicable to retrofitting buildings. Of course, that climate action, reducing the environmental impacts, improving, responsible consumption and production. Retrofitting to passive house standard is going to enable these buildings to be more efficient, creating more sustainable cities, more sustainable communities, improving the health and well-being of the building occupants. We all know, those of us who work on passive house projects, the additional benefits, comfort benefits from the thermal aspect, acoustical benefits from having additional information, air quality benefits, etc. So, and then of course, highlighting that partnerships for the goal. We're all in this together, manufacturers, organizations like Passive House, architects, designers, engineers. And so with that, we can get into the retrofit side and our solutions that we have to offer.
Yeah, thank you. So one of the solutions that we're going to highlight is the EIFS retrofit solutions, where it's certainly one of the more lower cost solutions to get into retrofits. Many people maybe don't know this, but you can actually use stone wool as a non-combustible exterior insulation alternative to rigid foams. So when we're looking at a stone wool solution or at a EIFS solution, we have to again look at our assembly layers, because we're going to take an existing structure and we need to make sure that we get a airtight and a continuous insulation envelope. So first of all, we have to focus on having a primary air control layer that can be different sorts of membranes, whether they're applied in a liquid format or maybe they are existing. And then we need to add our thermal control layer. And then finally, in the EIFS system, we're going to finish with a finish render and the reinforcing mesh to provide a proper surface cladding. Definitely what's important here in this solution is that you have proper drainage efficiency. So the stone wool solutions allow the type of materials that we can fabricate allow to create different types of geometrically defined drainage channels behind the insulation boards. There are different manufacturers that have different patterns. We need to provide a really good board that allows for this handling, and obviously is also a durable product. Using a dual density product would be helpful to adjust uneven surfaces in order to create a flush installation, and then by applying a fire resistant solution, you can get around issues such as buildings where you don't have any sprinkler systems installed. So an example of that, and I had to add this photo here, is the Ken Sobel Tower. I managed because the Passive House Conference Canada took place in Hamilton, in Ontario, from Monday to Wednesday, where we were present. I was able to go there and take a photo of this great project. So this is the Ken Sobel Tower. It's really an interesting project. The architect was ERA Architects, and the key challenge here in this project was a deteriorating facade. There was some mold. There was really a lack of thermal control, and most of the mechanical systems were at their end of life. So in order to provide a better envelope, a retrofit solution was chosen in order to get a really nice, really low energy envelope in order to reduce the greenhouse gas emissions. And then EnerFit certification was also an objective in this project. And to date, it is the biggest EnerFit certified project worldwide. Another important factor was, of course, the reduction of thermal bridging here, and passive climate resilience also was an important factor, because we were looking at the specific group of occupants in this low income housing building. It's low income, or it's senior housing. And so the passive survivability became really important. So here are some images of the installation board mechanically fixed, and then a base coat is applied. Here they were using 6 inches of semi-rigid stone wool. Obviously, on the back side, this is the puck system. There's like rounded pucks on the back with the drainage channels behind. And what was really interesting with regards to the survivability or to the passive resiliency of the project was some analysis that was done to evaluate the performance of the old and the new envelope over time. So what we can see in this, well, I don't know if I can get the mouse there, but what we can see here is the interior temperature of the building at regular temperatures. Here on the bottom part, we see the exterior temperatures. And what we were able to, well, I think it actually happened that there was a power outage, and you could see that in a relatively short time, within hours, the interior temperature drops so rapidly at temperatures of -20 because the envelope is so badly performing. And so people were basically forced to leave the building rather quickly. And an analysis was done to evaluate what would happen with this new envelope that is properly insulated and also airtight, obviously. And we can see here that it will take almost 2 days before people experience a temperature of 15 degrees, which is considered the survivability threshold for winter conditions. The similar analysis was also done for overheating. And with regards to overheating, the new envelope actually will maintain the temperature at a supportable level for up to 4 days. So let me just get my mouse back here. There we are. Insulation boards are engineered to help reduce the amount of base coat that you need in this stone wool EIFS solution. And it will help to create a more rigid surface so that it is more resistant to impact. At the same time, having a certain softness in the product allows you to adapt to irregularities of the wall. So this is a non-combustible insulation solution that you can use as an alternative, as a non-combustible alternative to the standard EIFS systems that we know. With that, I'm going to pass on to Robert.
Thank you, Mahnaz. Thank you, everybody, for being here today. I can see there's quite a few folks in the digital room. So I'm going to talk about different type of retrofits, so overcladding, rather than using our EIFS solution, overcladding with a clip and rail and semi-rigid board solution. So you go ahead and slide. As Mahnaz mentioned, control functions are really key here. On the right-hand side, we can see a section detail of what that overclad solution might look like. So, this is another version of a rain screen solution, the EIFS system being really kind of a micro rain screen, if you will. And so we look at, as we look at specifics on air and water control, we would generally, with retrofits, look at a liquid applied air and water barrier. Because of irregularities in surfaces, these seem to be go-to over sheet applied, as we see with new construction typically. So we can see that CMU wall, that dotted black line, which is going to serve as that primary air and water barrier. Then we have our exterior insulation, giving you the thermal control on the outside, and that's fastened in this instance directly to the structure in this. But you also might see the use of a clip and rail system to minimize thermal bridging. And then, of course, supported that are cladding. Some key things to think about here: structure is important, right? The substrate that we're attaching to certainly needs to have some analysis and be able to support the weight of a new cladding. In the case of the project we're going to look at, brick was there before, so that shouldn't be a problem. But given the age of this, or depending on the age of the retrofit you're looking at, that these are variables we want to take a pretty close look at. Slide, please. So the project that we're looking at is 201 East 79th Street in New York City. I think a pretty typical build for its vintage, built in 1963, much like Kensable Tower, no insulation. or waterproof membrane, or at least not any meaningful versions of either of those. Very deteriorated exterior masonry. This white glazed brick, which as we know is kind of aged poorly over time. The other factors that they're dealing with the project are the need to comply with local law 11. So I'm sure there's a good number of folks on the call in New York City. This is where I really cut my teeth on building envelope, right? So it's a facade inspection and safety program that's performed every 5 years, and with a requirement to follow up on the findings of the engineer. In the case of this building and many like it in New York, that means that your building probably has sidewalk bridging around it for years on end. So that gets expensive, and so does the cycle of continuing to maintenance these facades. Slide, please. So first step, of course, was doing some investigative work, looking at what that substrate looked like. Ultimately, the decision was made to remove all the brick and put in a new cladding system. Some of the other goals that they were looking at were to meet Plan NYC 2030, so carbon reduction goals of up to 30%. In the meantime, we also have seen the implementation of Local Law 97 in New York. So they happen to get ahead of that as well. They're looking to avoid the compliance fines around Local Law 97, as well as Local Law 11. Of course, we want to improve indoor comfort with the effort. This is a co-op building in New York. A lot of structures like this in this part of the city, and with some of the original occupants still there from 1963. Of course, they want to increase their property value, and big goal here, of course, is to come up with a better energy efficiency picture overall. Slide. So the brick was completely stripped. The CMU was parged and patched in a lot of areas, as there's definitely some vulnerabilities in terms of structure. A liquid applied WRB was implemented, and then they utilized a clip and rail system. So looking to minimize thermal bridging in attaching this new open joint porcelain rain screen. The insulation that they used was our cavity rock black. So that's our cavity rock material, dual density material with a black facer. That integrated black facer, of course, so that not everybody appreciates the beautiful greenish brown hue of our material. So really just a visual block, so that as sight lines through the open joint rain screen, it's basically blacked out. We'll concentrate less on the window portion of this. As you can see on the right there, that's not a brand new window that went in with the cladding system. We're really looking at the opaque part of the wall here. But then they used a stainless closure for flashing there for greater efficiency. Stainless steel, of course, being much less conductive than carbon steel, and we'll look at why that's important as we go through. Slide, please. So one thing I think that's important to look at as we look at overclads and cladding attachment in general is that we can add a bunch of insulation to the outside of our new build, but if we don't minimize thermal bridging, then we can lose a lot of our efficiency through that thermal loss. Slide, please. So we look at a couple different scenarios here. Oh, hang on a second. I think we're lagging. Can you click? There we go. It doubled. Okay. So what we're looking at here is the positive number efficiencies of different cladding systems. So what we're looking at there with I think kind of old school business as usual, continuous roll formed or extruded girts of metal that are a very low thermal efficiency, so only 30 to 50% thermal efficiency. Next, please. Same idea with, here we have a basic clip and rail system, but with no thermal break. These particular systems, very robust clips, so plate steel, not pressed metal, spreading those clips out by 3, 4, maybe 5 feet, getting up to 75% efficiency, but certainly somewhat difficult to use in terms of adjustability. And what we really want to look at is the next scenario, using some sort of thermally optimized clip. So in this case, it's a pultruded clip with that double cell structure in the middle of the clip, and then 2 fasteners that go through it. But these are the levels of efficiency we see. The range in those numbers really comes from what's the weight of the cladding. So the higher the cladding weight, of course, the more clips we have to use, the less thermally efficient we are. Also, the type of fastener that's used with this clip has a bearing. As I mentioned, stainless is more or less conductive than carbon steel. So if we use carbon steel fasteners instead of stainless fasteners, we see a diminished thermal efficiency. All of this fasteners add up, especially with a big facade. We're talking about thousands of small thermal bridges. Next. So the other option is to use a rigid board and screws that pass directly through it with a over applied girt, and we see similar numbers in terms of efficiency. In some cases, we see less cost because we've eliminated a layer of hardware. Again, that range in terms of efficiency comes from how many fasteners we're using, depending on the cladding weight, and what type of fastener, right? So stainless versus carbon steel. So these couple of projects here, all utilizing either horizontally or vertically applied girt to attach our structure to. Next. Just a real quick metric on everything from continuous vertical Zs, clearly the least efficient approach, all the way up to stainless steel screws, one of the most efficient approaches, and the range in terms of thermal efficiency that we see out of each of those. The material that was used in this instance was our cavity rock black, as I mentioned, a dual density product. So you can see in that image, if you look closely, that the material that's closest to the facer is of a different consistency, so a higher density, so the boards can be butted together and have a tight fit to each other, and then the back of it a bit softer to accommodate or form around the hardware that is being used with it, right? To form around the clips, and also to kind of suck up the irregularities in the wall on the substrate. Then we'll look at also an interior retrofit solution. When we look at doing retrofits, of course, we don't always have the luxury of cladding on the outside. We might be limited by our lot lines and setbacks. We might be limited by historic preservation efforts. So then we, of course, look at having to do that retrofit from the inside. So all of the same kind of properties apply, right? We need to look at a primary air control, again, over existing masonry. That is typically a fluid applied material. Look at at applying our thermal barrier. In this case, we're talking about a project in Brooklyn, 1701 Armoral Road. The goals here, of course, were efficiency first. Sustainability, occupant comfort, and wellness is going to come along with that. This building, also a co-op. This is a older Finnish co-op pre-war. So what you would expect out of this Finnish building, right? 3 whites of historic masonry. They're looking to, as a co-op organization, also satisfy local law 97. So those punitive measures begin to kick in here. Those punitive numbers begin to kick in here as New York starts to move towards net zero for all buildings, really kind of the same metrics as local law 97, buildings above 6 stories and generally over 20,000 square feet. So they wanted to improve thermal comfort with the building. They also wanted to improve acoustic performance. Clearly, these New York gets busier and busier, so hearing neighbors outside and hearing neighbors above and below was a component. There's the sensitivity to the moisture content and the durability. Of course, we know that as we potentially change the hydrothermal dynamics of a historic wall like this, we could have a pretty big impact on the long-term on the lassitude of the building, right? If we're restraining moisture in that brick in the heating season, that could be problematic. So we can see on the left here the pre-retrofit. Oh, can we go back one? Sorry. We can see on the left there a pre-retrofit photo, existing conditions. Again, 3 whites of historic masonry, no air barrier, single pane windows, and then we can see on the right the beginnings of the post-retrofit buildup. So, which included that liquid applied air barrier, a vapor permeable air and water control layer over the inside of 3 inches of semi-rigid stone wool. So really kind of doing this reverse engineering of a rain screen from the inside, and then additional thermal materials on top of that, which we'll see in the next slide. We can see that smart barrier that was applied between them, and I can go to the next slide now. So what the real key thing here was what's happening with moisture in all of this historic brick. A lot of thermal modeling was done on our part, and also along with the architect and the key passive house person, who was Jane Sanders with Scott Henson Architect. But really what we want to look at is keeping that moisture threshold, especially in the heating season, down below a certain mark. And in some cases, and I see this quite a bit in New England where I'm at, where we're doing a lot of historic restoration, even testing the brick to make sure that it's going to stand up to potential for the stranding of moisture in that brick during the season where all that warm moist air is going to be pushed out through the masonry. So the products that were used here were cavity rock or unfaced cavity rock. Typically this would be used outside, but this was a bit of an atypical application. So the key here is vapor permeability, allowing that wall to dry to the inside through the vapor permeable insulation, through that smart barrier, that Intello barrier that is the variable vapor permeance material that's keeping diffusion from pushing moisture out into the wall, but also allowing the drying to the inside. We also use comfort bat in the service cavity in the studs. That kind of 2-stage approach that was taken on the project was done because they wanted to maintain the integrity of the smart barrier inside of the cavity rock, and then have additional thermal insulation to hit those efficiency numbers, but also to allow for any activity that needed to happen in the service cavity post build out to occur. These are spaces that are going to be occupied by different folks over time, and they wanted to be able to not have that air barrier corrupted. And then between, you can go next slide, and then between floors, they utilized acoustic fire bat. So to deaden the sound. I don't know if you've noticed in the images, but there is also, it looked like a resilient channel used between floors to minimize the acoustic transmission between floors. So with a combination of those materials, we get a good solution for mitigating sound between from floor to floor. Next. So some additional considerations. I think that Alejandra is going to pick back up here and talk a little bit more about carbon embodiment and EPDs.
From as Rob was alluding to, just as we start retrofitting more buildings, as we build a passive house, of course we're increasing the efficiency of our buildings. But when we build more high performance buildings, what happens is the operational carbon emissions reduces and the embodied carbon starts increasing. So it starts becoming a bigger piece of that pie per se. And so of course we always have to consider the embodied carbon of the products that we're choosing to go into our building envelopes. And so from the lens of installation, I'm not going to go into real depth here in terms of how do we compare products from one another. Right now, what I'm just showing here is just a snapshot of some of the exterior insulations available in the market. It's by no means all of the insulations out there, and not necessarily honing in too hard on the numbers themselves, but really just understanding what are the considerations that we have to be aware of if we're going to start making product choices by looking at environmental product declarations that different manufacturers are putting out. And so when we look at the global warming potential values, it's a single number. And so you want to make sure that you're taking a big picture and understanding what are how are these EPDs being developed to make sure that if you're going to be comparing numbers, that you're comparing an apples to apples comparisons in terms of how the EPD, the methodology that was followed to create that EPD, what are some of the assumptions, what are the data sets, what product category rules are they using? Because in these cases, as we are familiar in past, I'm sure a lot of people on the call have done energy modeling. Your output is only as good as your input. And so if you're putting in different inputs from different sources, that can definitely change the output and not make it comparable. When it comes to looking at different products, again, as I said, I have just kind of a snapshot of some of the exterior insulations available out there. You're going to see a difference in performance, and why there's a difference is going to definitely be based on the type of product. What are the raw materials? What is the manufacturing process? Are they using any kind of additional ingredients that have high carbon intensities, such as blowing agents? And then, of course, you always want to consider things beyond just that initial product stage. It's really critical, for a life cycle assessment to assess the full life cycle of a product. With honing in on stone wool in itself and rock wool specifically, we've done some in situ studies to look at what that impact is in terms of reduction of carbon emissions from the insulation that has been produced and sold into the market. Again, this is the third-party verified document available on our website, but really you can see that, it's anywhere between 100 and 150 times the operational carbon savings than the embodied carbon emissions emitted for the production of that product. And so I think that just speaks volumes to how important insulation is to reach these climate goals that we have to look at. I saw really quickly, and on one of the questions in the chat was, looking at comparison numbers between mineral wool insulations. And again, it's very tricky to compare one EPD versus another just because there's so many differences that go into it. What I have here on the screen is some differences in between some of the mineral wool insulations that are out there. And so the red being ROCKWOOL, the gray being competitors, and the light gray being an industry value. And what I want you to take away from this is primarily not just how these different companies perform, because ultimately, we can get into a little bit more on the Q&A if we need to, but I really wanted to highlight that when we're thinking about mineral wool insulation, it's really, really important to ensure that if we're looking up the global warming potential value or any other environment impact on an EPD and comparing it to another product, you have to ensure that you're comparing like-to-like products. Because mineral insulation has a full range of products, we make anything from a light density bat that is comparable to, from an applications perspective, to a fiberglass, to high density boards that's comparable to, a polyiso and XPS, and even medium density boards that's kind of like that in between for exterior applications. You want to make sure that you're not comparing a high density mineral board GWP to fiberglass, because you're not comparing like to like applications. So I definitely wanted to kind of highlight that when you're making these assessments. And of course, EPDs are great. Looking at the global potential is great, but there's so much beyond that. Some of the other environmental factors that are included in an EPD, for example, include ozone depletion, but even looking at products more holistically in terms of, are these products contributing to what we consider that circular economy? Are they circular by nature? What about the health and safety? Fire. Rob's going to touch about that a little bit about that in the coming slides as well.
Thank you, Alejandra. So I think, we look at the slide, what we're generally talking about here is, change in climate and the increase in frequency and severity of wildfires. This isn't just California anymore. Very specifically, when we look at the Marshall fires in Colorado, these events are becoming more and more commonplace. We are actually participating on a panel coming up for the Passive House Network Conference in Denver to speak very specifically about the benefits of passive house when it comes to passive survivability, not only for occupants, but also of the structure, the benefits of airtightness and non-combustible installations in these areas. Even where I live north of Boston, in Cape Ann, we saw repetitive wildfires in an area where I would never have imagined that to be something that we would be talking about, but here we are. Very specifically, if you go to the next slide, please. Very specifically, if we look at some considerations around specific to our thermal barriers, like Alejandra was saying, in terms of making like-to-like comparisons, there's some factors around each of these materials that we need to look at. R value is not a constant for most everything. In some cases, it's not as published. Some materials change their R value over time. All materials are temperature dependent, so that can be due to the physical properties of the material. It could also be, or the chemical properties of the material. It could also be dependent on what the material does when it gets hot and cold, right? We know that thermoset and resin set plastics expand and contract quite a bit as temperatures change, and then also some thoughts around vapor permeability and acoustic performance. Slide, please. Just real quickly around aged R value, stone wool and mineral wools, fibrous insulations get their R value from trapping air, and XPS and polyiso get their R values, or at least a piece of it, from a blowing agent. And over time, that blowing agent condenses or off gases, and when that happens, we all kind of land in the same bucket for long-term performance. So as we look at all of the different points of data while we compare these materials, it's important to have a realization that that's a component as well. And so just to quickly summarize, we know that climate change is a reality, and when we look at how we're doing retrofits, things that we need to consider, right? So what's our embodied carbon and versus our operational carbon, the materials that we select. We want to minimize the carbon attributed to the measures that we're taking. With climate change in mind, that added thermal resilience is an obvious key. And then as we look at as we're enhancing that envelope, we want to make sure that we're making it last for as long as possible. We're typically taking a ferroconcrete frame that's got a lot of carbon already associated with it. We want to make that effort go as far as possible, and then also look at, of course, occupant comfort, getting to be as big a concern, of course, as making the building more efficient. And that's it. I see that we have a ton of questions in the chat, and I expect nothing less. I think the last presentation that we did had as much time for Q&A as it did for presentations, so I'm looking forward to that. One thing I want to mention before we jump into it is that if you want to pop up the RBS slide, the structure of your building affect your thermal package to 3D effective R values. So much deeper dive on thermal modeling, basic dew point analysis, hydrothermal modeling, WUFI passive. We support the Passive House ribbon through PHN, all the way up to full building modeling. And we're now also doing acoustic modeling. So it is a non-proprietary and complementary service that we provide. You can reach out to any of us to talk about being able to help you out with that.
Fantastic. Robert, Alejandra, and Mahnaz, thank you so much. That was an excellent presentation, and we do have a lot of questions, so let's jump right into those. The first one is with Rosmal Seneviratne. Hopefully I got close on the pronunciation of your name. You had a series of questions. Some of them may have been answered by the comparison charts that Alejandra was sharing, but please follow up with any questions you got. All right, I am not seeing an unmute, so I'm going to go ahead and walk through them. So the first one was, can you compare energy expended to create mineral wool, rock wool versus glass wool, fiberglass? Second is the different, and then maybe I'll just go through all four, and you could answer them as a group. So yeah, so then the difference, then also like pros and cons between rock wool and fiberglass, price differences, sustainability comparison.
So I can handle, I guess, the sustainability focused questions on that first, and then hand it over to Mahnaz or Rob. But as I was sharing in some of the slides afterwards, we've got to be really careful when we're making comparisons. I always like to caveat with that. You want to make like-to-like comparisons, but there's definitely differences and similarities with fiberglass insulation and mineral wool insulation. So in both cases, we are, fibrous insulations, we are melting down these raw ingredients to create these, in the case of fiberglass and light density, batt products to fit in between wood studs or steel studs in that sense. And so for the most part, both of them are going to be relatively carbon intensive in that, they have to get to high temperatures to melt these raw ingredients, whether it be the glass or the stone that's being used in these products. Another factor that contributes towards, I guess, the differences in terms of the environmental performance is the density comparisons. So fiberglass is a much lighter density product than a mineral wool batt is. And so there are reasons why we have a higher density batt instead of just having a lower one. From a performance standpoint, a lot of that has to do with long-term thermal performance, long-term durability, making sure that these batts have a friction fit in between the studs so that they don't slag and slump over time. Make sure so you have that continuity of that thermal performance throughout the life cycle, throughout the lifetime of the building. And I will throw it off to Mahnaz or Rob to touch upon maybe some conversations on price or specification differences that you have insight into that I perhaps do not.
I'll jump in there real quick. So the one thing in making that price comparison, certainly glass fiber is less expensive than the material that you would use in the same position, right? Our batt is definitely more expensive than a glass fiber batt, but it does a much different job than that glass fiber batt. It has a different sound quality. It has a higher R value, roughly 15% higher R value. It is fire resistant, whereas glass wool will just melt when at the same, at a much lower temperature. And it performs much differently over time, right? Our material doesn't slump in the wall. If it gets wet, it stays, it holds its form. Typically glass fiber, if you're in the unfortunate situation where you have an elevated moisture content in the wall, it can get saturated and sink and then create really a gap in the thermal barrier. I mean, those are the big three that I would say. So it's a little bit of an apples and oranges consideration. And then lastly, when we look at the cost of insulation as, we get the most bang for our buck out of insulation. So if we're, trying to pinch pennies on what insulation we use, but the approach that we're taking might not be, we might want to consider that approach, right? It's worth spending a little bit on things that save us the most energy. And I would say the same applies to air barriers and vapor barriers and all of our other control continuity.
Excellent, well said. Thank you. So it looks like Jeff Eckes's question was answered. So next up is Justin Taylor. And Justin, it looks like you are still on the call. If you're able to unmute. Okay, Justin, I'm going to ask you a question for you, and that is, do you have people working solely on aggregating data for SDG compliance?
So I will take that one there. So the short answer is yes. The long answer is we've got a series of people in different roles within our organization here in North America, tracking our performance, tracking our emissions. And then we've got, from a group perspective, track against all of our SDG goals. We've got a TMAC group that's consolidating all of the different factories throughout the entire globe, aggregating all that information to get to to measure the KPIs and how far along we are in meeting these targets. So yes, there are multiple people within the immediate and extended organization focused on sustainability, essentially.
Fantastic, thanks. So it looks like Eric Bosley is not on the call anymore. So let's jump to Michael Nagel. Michael, you're up.
Yeah, my question was about whether or not the on the existing building where they had the overclad, whether there was a hydrothermal analysis considering there's insulation inboard of the existing wall and outboard.
Yeah, I'd say that's one of the services that we actually offer through our building science department. So we use WUFI internally, not me myself, but my colleagues, Antoine and Ali. And yeah, so when we make recommendations for wall assemblies, I can tell you they're typically very conservative because we always pay attention to dew point analysis and potential risks when you're using vapor barriers and we're relying on it to be really perfect. So we really look at it very critically.
Great, thank you. Michael, are you good?
Yep.
All right, awesome. So Hans.
I've seen ROCKWOOL being used around foundations, and I was wondering if there's any standard details there. Oh, on the outside of the foundation, not the inside.
Yeah. We do actually have construction details or CAT or DWG.
Oops, I think it just muted. Sorry.
Okay, you can use stone wool as your foundation insulation. Obviously, you need to install it in a system where if there is actually water accumulating, that it can go somewhere so it can be drained away. Yeah. So you have a French drain system, for example, installed.
Yeah. And we have details available on our website that are full building enclosure. So everything from the foundation up to roofing for, residential or, medium-sized commercial buildings that kind of show, at least certain methods of how to achieve that from a detailing perspective.
Okay, excellent. So next up we have Sylvia Valencia.
Hi, how are you? Great presentation, everyone. So my question is about front rock is available in Mexico, because last time I checked, it wasn't. So I think EIFS system is becoming popular here over Mexico, but I think I'm sorry, I see people is still afraid about the capillarity problem, so they don't use it so much. But actually, we don't have a solution with fibers, insulation fibers, right? So my question is, it will be available here in Mexico? I mean, front rock. Sorry.
We have different approaches for the different regions. In Canada, we have a number of manufacturers that actually buy specifically designed board insulation that they will then convert. So they will be adding their drainage channels according to their requirements or their design principles to create their own proprietary solution. For the US, Robert, I don't know if you want to add to that.
Yeah, I can't directly speak to what our availability or how we're going to go to market in Mexico, but I know that in the US, it is coming through the different manufacturers, right? So I think when in talking to Michael Ingui earlier today, so that they were using the Drive It system on a project that they're doing in New York. and Master Build Solutions, formerly BASF. Synergy System is another. So there are that product is generally going to be coming through the system providers in the US. And I have to imagine that the same is going to be true in Mexico. But I'm more than happy to do a little digging on that and get back to you offline.
Okay. Yeah, it will be helpful. Thank you.
Yeah, sure. I'll post my my email again in the chat.
Yes, please. Thank you.
Yeah.
Thank you, Sylvia. I wanted to go back to Eric Bosley's question. He's not here, but I think it's an interesting one. And he asks, do you know if the insurance industry is looking at EIFS differently using stone wool versus foam? So that's sort of the general question. And then he says, my understanding is that it's unacceptable in single family residential, but EIFS with wool is vapor permeable, alleviating a lot of the problem, ? So
I'll
that's
speak to that in a more general sense.
Yeah.
I've been, in a lot of course, a lot of the folks that I'm in contact with through the architectural channels they're institutional, they're universities, they're folks that are dealing with Factory Mutual, right, with FM Global. And FM Global and other insurance organizations like that are moving away from plastic foams, from resin set and thermoset plastics overall because of flammability issues. But I don't know that anybody has looked at it from a building science perspective. And clearly, post-90s condo crisis, it's always been my contention that having your insulative substrate in an EIFS system work like a drainage plane rather than a sponge seems to be the best approach, because we all know that the details don't always get executed in the way that we'd like to see them get executed.
Well, I think that gets us through the questions. Unless Kim, are there any that I'm missing here?
I think there was one from Kevin.
Oh, great.
Yeah. Quick question on recyclability. So it's great that that ROCKWOOL is recyclable, but if there's no places to collect it, no places that provide those services. So like in Michigan here, drywall is highly recyclable, but we have 0 spots for drywall to be collected and recycled. So what would your guidance be on that, or what's in the works for that?
So you want to take this one, Ali?
If you don't mind, I'll take this one.
Sure.
As I mentioned earlier on, we definitely have, one of our goals is to kind of increase that capacity of reclaimed material programs throughout globally throughout. In North America, as you can imagine, we are such a large geography that can be a challenge. Yes, we are 100% recyclable. We can take that back, reprocess it. What we've done here in North America to date, we've done some pilots with some OEM customers who are essentially kind of prefabricating something in their own facility, and then we can take that back. There is, it is a very large opportunity, I think, in our market to come up with solution of how to do that efficiently in terms of financially efficient, but also environmentally efficient. And so that's going to take kind of a community holistic collaboration between multiple different streams to come up with proper solutions that include the manufacturer, that includes waste handlers locally and national ones to agree to do this. It's going to take also the construction industry to adopt new methods of how they handle their waste, right? Yeah. We are definitely seeing an increase in how, wanting to recycle more, specifically, if I focus on new construction, they definitely got some more stringency in terms of putting different recycling streams, but primarily right now, construction sites are focused on, the big items, the high volume items that are kind of going to get there to their target. So they're focusing on like the wood, the steel, you know, if we're talking retrofit, the concrete, whatever the case is, because oftentimes that's what's going to get there. One of the challenges that we have, not from also from a logistics standpoint, that makes it a little bit more harder to implement from a cost and just environmental standpoint, is we're a relatively light product. And so, you know, shipping a light product, you know, from one place to another, that's not necessarily on site on a construction site, packed in an efficient way and in a very compact way, can be a challenge. And so from us here in North America, we're actively looking at engaging with, you know, leaders in the industry who want to find a solution, essentially, who want to work together collaboratively to find a solution. And I think I can speak to all manufacturers who are looking into this, that we really need kind of a holistic approach. We need, like I said, ourselves as manufacturers to commit to wanting to implement that. We need the waste handling infrastructure to assist. And, you know, bottom line, we need the commitment from the designers to hard spec that, and or the contractors to change their mindset and, you know, learn how to do this properly and effectively in that sense. So we're actively looking at it, engaging in it. It is going to probably take some time until we have, you know, full-blown programs in place. But that is where we're at right now.
And, you know, we're really just starting to scratch the surface with designing for deconstruction too, as we look forward.
I mean, the other thing that is interesting in all of this aspect is to look at, well, one part is whatever remains from your site as materials that haven't been used, that are end pieces or whatever. And then the other thing is in retrofits or building additions. I just had another project where they basically took apart a building or part of the building because they're making it bigger, and they have a rock wool. It's stored in a container and they're just waiting to put it back on. And that's around 40 years old. We also have that Denmark example where they actually took out a 65-year-old sample and were able to test it and confirm that it's still functioning. So I hope that the reuse is going to be explored more. But of course, that takes the commitment of contractors and architects to accept that. Because the easiest thing is to reuse before we go to recycle. Because that way you reduce all of your transportation, or a big chunk of the transportation. You don't need to put energy into transforming it again. So that is an aspect that should be expanded upon, that you have building materials that you can actually reuse.
Yeah, totally.
Thank you.
Great. Yeah, great question. And a whole evolution of practice in the community that we want to see move forward for sure. So we have a question from Peter about thermal imaging.
Mm-hmm.
Just, has any thermal imaging data been collected at sites that have been, built for a while, and to just demonstrate the proficiency of ROCKWOOL? I've installed it since 30 years ago. It's fun.
I don't think we've done particular analysis to look at by thermal imaging to look at existing projects. We've done lots of research. We've done research on the performance when the product is exposed to water. How does water on the surface impact the thermal performance? But I don't really know if we have any specific research where we do thermal imaging of. Yeah. I think it would basically just show where you find thermal bridging, because the product as such is tested for its thermal performance through the ASTM C513 hot box testing. So we know what the thermal performance is. We have samples, like the oldest sample we got now is 65 years old, where we could say it's still doing its job. But in a project I don't know of any particular infrared imaging that has been done.
I would guess that our friends in the consulting world have probably a fantastic collection of IR images, especially with everybody being able to plug a little dongle into your phone and from FLIR and take thermal images of reasonable quality at will.
Great.
Yeah, it'd be just a bit interesting to amass some of that data in one library. Go ahead.
Now we need Rob Hoskin on the job here.
Nice.
Well, fantastic. I think that concludes our questions. And I want to thank everybody in the audience for joining us today. We had over 150 people to attend today's Component Spotlight. A big thank you to Alejandra and Rob and Mahnaz for your excellent presentation and this great discussion. Before we close up, is there anything that you'd like to add as any closing thoughts?
I just want to invite everyone to download our sustainability report that you can find on our webpage, because you will get more details than what we presented today. But I think it's a really good statement or like a good business card for ROCKWOOL to show that we're not just talking about doing something, but we're actually, put some really tight goals for ourselves and have somebody else evaluate us upon that. And that is public. So I think that's interesting if you're interested in sustainability to have a look at what we're doing.
Thanks, Mahnaz. And I'll note that Kim just included a link to that report or to your website in the chat. So you can easily get to the website and navigate to the report there.
Yes, excellent.
Great. Well, Alejandra and Rob, are you good? Should we close
up? The other thing I wanted to say, I guess, is that we're looking forward to seeing a lot of you at PHN in Denver and at FIASCon in Houston. We're supporting both at a pretty high level, and looking forward to seeing you guys in person now that we can do that again.
Fantastic. Well, thank you for underwriting so many of these efforts in the PassFest community. We really appreciate that. And everybody, thanks again. It was great to see you today virtually, and have a great rest of your Thursday. We'll see you next time.